Match problem 4 is, again, the same type of question. We want to identify any critical values and then determine where our function is increasing or decreasing. So to get things started off, we first want to rewrite that function 1 over x, excuse me, as x to the negative first. And then we can take the derivative and find that that's going to be negative x to negative second. And similar to match problem 3, we'll actually want to be sure to rewrite this with positive exponents so that we can see clearly this function can never be equal to 0 because there are no variables in the numerator, but it is possible, or we need to check to see if it's possible, for our function to have a 0 in the denominator. If so, we're going to have values where our derivative function does not exist. So x squared is going to equal 0 anytime x equals 0. So that gives us our critical value. And again, it's a point where our derivative is undefined. So we need to choose test points on either side of our critical value and determine what values, or whether our function is increasing or decreasing. So our derivative function evaluated at -1 will give us -1. So our function starts off decreasing, we hit our critical value, and then for values greater than 0, so if we evaluate our derivative function at 1, we get -1. So we pass that critical value, and our function is still decreasing. So what we can say is that our function is decreasing on -infinity to, and now the question becomes to what? So in this case, we can't say from -infinity to infinity because we do have this undefined critical value, the point where our derivative doesn't exist. So we need to check back with the original function. In this case, 1 divided by 0 is also going to be undefined. So the original function is not defined at 0, so we can't say that it's decreasing at 0, but we can say it's decreasing up to 0 and then continues decreasing from 0 to infinity. So again, our answer here is a little bit different than in match problem 3 because we have to have that break at 0 because the original function is undefined at 0. In match problem 3, the function was continuous for all values of x. Here we have a break in the graph, so we have to represent that with our intervals of decreasing as well.